All right, jumping to this, we're going to talk about the more things change. And we see the quote that we have here: God grant me the serenity to accept the things that I cannot change, the courage to change the things that I can, and the wisdom to know the difference. So, this whole lecture is going to be about change. So, we're going to describe the states of matter, and then we're going to describe the similarities and differences of, and this is really important here, elements, compounds, homogeneous mixtures, and heterogeneous mixtures. We need to know those. We want to describe an object by its chemical and physical properties and distinguish between chemical and physical changes. Some good definitions that we need to know there, and we'll jump into those and try to explain them a little bit more. Now, what we already know, we should know that matter can exist as a solid, liquid, or as gases. Samples have different properties that can be used to distinguish them, and that matter can react with other types of matter. And so we can know those things. What we should have learned in the lab: baking soda is a chalky white powder that does not react with the calcium chloride. The calcium chloride was fine white powder, sometimes in pellets, but that does not react with the calcium, or that doesn't react with the baking soda. And then the acetic acid, that vinegar smelling liquid, it's clear, that forms bubbles when it reacted with the mixture of the calcium chloride and the baking soda. What we should have also learned is the reactants combine to produce a brand new product. One of the things we should have felt was that the bag felt cold. Lastly, the mass of the bag is the same before and after, and that just goes back to the law of conservation of mass. Matter. Now, when we're looking at matter we can define by its state: solid, liquid, gas, plasma, and we talked about that before. But just looking at if it's solid, is a liquid, is a gas, or it's a plasma doesn't really tell the whole story. So we need to break it down into basically different categories, break down that matter. So the first thing we look at it is it's pure. A pure substance, those are composed of a single element or compound. That's what a pure substance is. Um, when we look at a pure substance, we see that pure substances are homogeneous composition, meaning they're the same throughout. They're identical in all parts of the sample and identical in chemical and physical properties. Now, we said that a pure substance is a single element or a single compound. So let's define what type of element that, or what an element is and what a compound is. So if it's a pure substance, we have to look at how many types of atoms are there. If there's one single type of atom, we know that that's an element. So we can take example of this. This would represent basically a oxygen atom. So if there's just one oxygen atom, or just a bunch of just single oxygen atoms, then we have an element. If there's more than one type of atom there, we have a compound, which compounds have multiple, sometimes different atoms all arranged in the same way. So if we have a bunch, and this would be an example of water right here, the oxygen would be right there, and then we see the hydrogens up here. If we just had a bunch of H2O floating around, it's still pure substance. That would just be a compound. So if it's not pure, so what if it's not a single atom or a compound? Well, we have two other categories. So if it's not pure, we have what we call homogeneous mixtures and heterogeneous mixtures. Now, homogeneous mixture, that's a solution that is uniform combination of two or more substances, such as milk. And milk is considered a colloid, but what we can say here is that we can't see, and the main thing with the homogeneous mixture, you can't see stuff floating in it. You can't see little particles floating in throughout it. It's just basically the same. We look at that whole thing and it's a brown cup of chocolate milk. There's not anything floating in it. A heterogeneous mixture, that is non-uniform composition of two or more substances, such as orange juice. And so we look at this orange juice that we have right here, and we can see there's the orange juice, and then there's something floating in it. And if you can see particles floating in it, then it's a heterogeneous mixture. If you can't see particles floating in it, it looks basically the same. That's a homogeneous mixture. So we break everything down into this type of flow chart. So everything is made of matter. Everything that we can see, touch, hear, all that stuff, that's made of matter. Um, and then we ask ourselves, can that matter be separated into different things? And we'll go to one side. So if it can, yes, it can be separated. Then we have a mixture. And all we ask ourselves, is the mixture the same throughout? Can we see things floating in it? If we can't, meaning it is the same throughout, then we have our homogeneous mixture. If you do see things floating in it, it is not the same throughout, then we have our heterogeneous mixture. Then we come back here to the top of it and we have matter. Can it be separated into two different things? If we say no, it's an element, can't be separated. It's a compound, can't be separated. Then we ask ourselves, is there more than one type of atom present? If no, it's a single atom present or single element present, then we know that we just have an element. But if there's more, yes, there's more than one type of atom present, then we know that that's a compound. Now, since we can separate mixtures, because that was one of the things in the flow chart here, can the matter be separated? Mixtures can be separated. So how do we separate it? Well, we use different type of separation techniques, and this is just a separation of mixtures. So filtration is when a filter traps the solid particles and the liquid part runs through the filter. This is just like a Brita water filter. It traps that solid minerals in it, and then it allows the rest of the water to flow through. Distillation is when the liquid portion is evaporated off, leaving the solid. That you can think of this, how they get gasoline. They take that crude oil and they distill it. They refine it so that they get the very specific liquid that boils off, and that is able to do that because of different boiling points. Other separations of mixtures, we have decanting. That's when the liquid is poured off as the solid settled to the bottom. And then a centrifuge. If you've ever watched some CSI or anything like that, you've probably seen a centrifuge. It's when they take it and spin the substance around really, really quick, so that the components with different densities separate out. And then one that you might have seen is paper chromatography, and that's where you can do this with ink. And if you put ink basically on the bottom, and you allow a liquid, set the paper in a liquid, the liquid will flow up through the paper, and the different particles will separate out on the paper. And that's paper chromatography. So let's look at this first example. It says classify the following substance as an element, compound, homogeneous mixture, heterogeneous mixture. And so when we're looking at this, we see that we have some molecules up here, some compounds up here, and the same thing on the bottom, and they're kind of separated out. So it's going to be a mixture. It's a mixture of some compounds, and since they're separated out, you have some on top, some on bottom, they're separated in such a way that you could probably see a difference. So you can see some stuff floating in it. So this would be a heterogeneous mixture. You can see the different parts. So it would be a heterogeneous mixture. The next one is classify the following substance as an element, compound, homogeneous mixture, of heterogeneous mixture. Well, this is what we call a brass instrument. It's a brass instrument, and brass is actually an alloy, and so therefore it's a mixture of different elements. And so when we're looking at it, you can't see anything floating or kind of speckled throughout that brass. It just looks like one continuous thing. So since it is a mixture and you can't see anything floating in it, that's a homogeneous mixture. And then lastly, it says the human blood is a heterogeneous mixture. Plasmapheresis is the process by which blood is removed from the body, separated into its cells and the plasma. The plasma is then returned to the body. Determine the most effective method for separating the blood cells from the plasma. When we would do this, we would use a centrifuge. We use that centrifuge to separate it out because the different blood cells are going to have different densities. And then what we can do is we can use a little filter to filter them after we put it through that centrifuge to kind of speed it up. And and we can return the plasma back to the body. Now let's jump into physical properties. Now, a physical property, it is a description of an object that is not related to its ability to change to another substance. And so basically we're looking at just what it is and not what it can react with something else with. So is density a physical property? Well, yes, it would be, because it is measuring what it is and not what it can do to react with something else. Now, a list of physical properties that we have, those would be mass, color, temperature, absorption, malleability, area, pressure, specific heat, viscosity, density, boiling point, freezing point, brittleness, magnetism, and the rest of those. And basically what these are, remember, when you're looking at them or when you're measuring them, you don't change what that substance is. To measure the mass, you don't have to change what that substance is to measure mass. You just put it on a scale or a digital balance, and you can figure out what the mass is. And basically you can test all of these without actually changing the substance. So when we looked in the lab, did any of the following change the composition of the fluid in the bag? We think about that. Mixing the calcium with the baking soda, did that change anything? No, that really didn't change anything. It was only when we mixed the acetic acid with everything else that it ended up changing it. Now, when something changes and we're looking at the changes of it and how it reacts with something else, it's a chemical property. A chemical property is a description of what will happen when or how an object can change into something else. So this is how it changes into something else. So when we're looking at this, we're just looking at how it changes and reacts with other substances. So when we're looking at this, is electroconductivity a chemical property? Remember, when we're looking at these physical properties, we could measure them without changing it. Can we look at electrical conductivity without changing the substance that we're looking at? Jumping into a list of chemical properties, we have combustibility, emitting light, reactivity, ability to change colors. Those would all be chemical properties. Now, the one thing here is to test these to figure out what the chemical properties are. If you were to figure out that something is combustible, you would actually have to combust it. And so it changes what that substance is by looking at that property. And so that is different than that physical property because you had to change it just to figure out what the property was. So let's describe the physical and chemical properties of gasoline. Now, one of the gasoline, the chemical properties is it's flammable. We know that if to test that, you actually have to test this flammable, but you have to light it on fire, which you shouldn't do. But some of the physical properties, we could look at the density of gasoline. We could look at the color of gasoline, and those would be physical properties. Next one, it says which of the following physical properties, so we're just looking at physical properties, could be associated with this sample of titanium. All are true about titanium. So all of these are true about titanium, but which one is a physical property? So we have specific heat, that would be physical. Melting point, that would be physical. It reacts with oxygen. To test to see if it reacted with oxygen, we would actually have to react it. So that would be a chemical property. That's how it's reacting, or how it reacts with something else. But density, on the other hand, that would be a physical property. So specific heat, melting point, and density. This question, it says archaeologists uncovered what they believe to be an original copy of the Magna Carta from 1215. What type of properties should be examined given the unique artifact? So when we're looking at this, we don't want to measure the chemical properties of it because that would destroy the document, and we don't want to do that. We just want to look at the physical properties and try to determine some things from that because we don't want to destroy something that is so old. Now, looking back to the lab, mixing the powders did nothing. But what happened when we added the acetic acid? What we should see is that when we added that acetic acid, something changed. We had a chemical change. So just mixing those two powders together We just had a physical change. We just changed what they were next to, but nothing chemically happened. So a physical change is something that changes the form, but not the identity of the substance. Key thing here, it didn't turn into something new. If we place a cup of water in the freezer, is it still water when it turns into a solid? Well, yeah, it's still H2O. Chemically, it's H2O, and that would be our liquid, and then guess what? When it's a solid, it's still H2O. That's a physical change. We didn't change what it was. Now, evidences of a a physical change in shape, state, temperature, or texture. Those are some evidences for a physical change. Now, chemical change, on the other hand, that is the process by which a substance is changed into something new. So once that acetic acid was mixed with that calcium chloride and baking soda, it changed those into something new. So if we place a cup of water through an electrical current running through it, and it causes what we call electrolysis, it'll break it apart. Well, this is H2O. This over here would be hydrogen gas, and this would be oxygen gas. Now, hydrogen gas and oxygen gas are much different than water, so they changed into something new. That would be a chemical change. So, evidences for a chemical change is the producing of a gas or bubbling. This would be producing is the key word here. If you just open up a can of Coke, yeah, you're going to see bubbles, but was it produced by a chemical reaction? Well, no. Change in temperature, meaning it heats up or cools down. Substances disappear. They really don't disappear. They probably turn into a gas. A precipitate forms, and that's when you have two liquids and a little solid. You mix them together, and then solid floats out of it. Color change. Odor is produced, so it produces an odor. An apparent change in mass. Those would be evidence for chemical changes. So let's jump into an example. It says, what type of change is easily reversed without changing the structure of a substance? So what's really easy to reverse without changing the structure of the substance, so it's not anything new? That would be a physical property, because we're not changing what it is. Very easily reversed. Chemical properties are not easily reversed. Next one, in the following picture, describe what type of change is occurring. So when we're looking at this is just a bowl of dry ice, which we would call it sublimation. So it's going from a solid into a gas. Well, that's still just a physical change, not a chemical change, just a physical change, because it's going straight into a gaseous state. And then our last example says name one example of a physical change and a chemical change done in the kitchen when preparing a meal. So a physical change would be something like chopping up. So if you had some chicken that you chop up into little pieces, that's a chemical change, or a physical change, because you're making the pieces basically smaller. You're not changing what it is, you're just making it smaller. Chemical change would be actually cooking something, so baking a cake that changes the chemical structure of it and has everything react with it.